Here we have an exponential functions application problem. In a lab, the number of E. coli exponentially are growing at the growth rate of 0.41 hours per second, and initial amount present is 1000. Now we have learned that exponential functions are y naught e the power kt, where y naught is initial value, which is given as 1000 in this case, right here, and k is the growth rate. Growth rate is usually positive, which is given to be 0.41 in this case. Therefore, if pt denotes the number of E. coli at time t, what is the formula for pt? Using our formula, pt, population of E. coli at time t, would be 1000 in place of y naught 1000 times e raised to power 0.41 t. So that is just the answer of the first part. How large is the population after 5 hours? So now you have to fill t equal to, they are asking you to find the population function at 5. All you have to do is replace t by 5000 times e to the power 0.41 times 5. You can easily find that putting in the calculator. 1000 times e raised to power 0.41 times 5. 7767 point something. So we can round off here. Okay. C. When will the population be 10,000? That means when will PT be 10,000? You need to find T. The question is to find T. So PT is this function. Therefore, we have 1000 e to the power 0.41 t is equal to 10,000. Divide by 1000 on both sides. That will be 10. Therefore, e to the power 0.41 t is equal to 10. How do you get rid of e? So you need to take natural log on each side. When you take natural log, e will cancel. So what do we really have? 0.41 t. So natural log and e cancel each other. What do we left with? Natural log of 10. T is equal to natural log of 10 divided by 0.41. Again, you can easily calculate that from your calculator. 10 divided by natural log, sorry, what was it? Natural log of 10 divided by 0.41. 5.61. So about in 5.61 hours, the population will become 10,000. That is the answer. This is time in which the population of the E. coli will become 10,000.